Hi guys, welcome back to another video. So today I've got another MIT integration B question. So here we have the integral of x over 1 minus x to the power of 4 dx. If you would like to give this problem a go, you can pause the video now. All right, are you ready? So I'm going to show you how to do this question. So here we have x over 1 minus x to the power of 4. So what my mind thinks here is x to the power of 4 is x squared, like this. Why do I think this way? Well, if we have if we have the function x squared and we differentiate with respect to x, we get 2x. But if we have x to the power 4 and we try to differentiate this with respect to x, it is 4x cubed. In the integrand, we don't have x cubed, but we have x. So in order to use a potential u sub or integration by substitution, we think of x to the power 4x x squared, which makes it easier, or which enables us to at least get rid of x here. Like we can replace x dx with something, right? So if we use, I mean, like using this information, we can set u equal x squared, and because of this, that means du is equal to 2x dx. So the integral can be restated as, I mean, 1 minus x to the power 4 dx is equal to the integral of, I'm gonna write it here, the integral of, so notice that here x dx appears, and it appears in the integral. There you go. And from here, we get x dx is equal to 1/2 du. So that means this integral becomes du over 1 minus. So notice that x to the power 4 here is x squared, and x squared is equal to u. So that means this is u squared. All right. Now, this integral. Oh, I forgot. There's actually a 1/2 here. So this integral is quite a standard integral in your calculus courses, where you usually encounter how to substitute expressions using trigonometric functions. So uh, recall that recall this uh, trigonometric identity of sine squared theta plus cosine squared theta equals 1. So this, among with two other identities, which are obtained by dividing both sides by sine squared and cosine squared. So like the other two are 1 plus cotangent squared theta equals, this is, so this is division by sine of theta. That means 1 over sine is cosecant squared theta. And then the other one is obtained by dividing both sides by cosine squared of theta. So this is tangent squared theta plus 1 equals secant squared theta. So for these kinds of forms, 1 minus u squared. So like if you have a difference between two squares, usually the identity that you would like to use has to do with sine theta and cosine theta. Meanwhile, if you have a sum of squares, it's usually either the cotangent or a tangent. So in this case, the first guess that we can use, it's not really the first guess because I already know how to solve it. So if you see a difference between squares like this, usually you will need to use the uh, identity with sine and cosine because because 1 minus, let's say, sine squared theta is equal to cosine squared theta, right? So let's try this. If we try u equals sine of theta, that means du is going to be, so we differentiate sine of theta with respect to theta, which is cosine of theta, theta. So we can rewrite this integral as 1/2 times the integral of cos theta d theta over 1 minus sine squared theta. Now recall that sine squared theta, 1 minus sine squared theta is cosine squared theta, which means this is 1/2 integral cosine theta d theta over cosine squared theta. And notice that here we can cancel out 1 power of cosine theta from both. So what remains is 1/2 times the integral of d theta over cosine of theta, or 1/2 the integral of second of theta, d theta. All right, so the integral of second theta d theta. This looks simple, but there's actually a trick, and this trick is actually quite commonly taught in, again, your usual calculus courses. So to evaluate the integral of second theta d theta, there's a trick by which you multiply second theta by a smart choice of 1 over 1. So like you multiply second of theta by something over something where both things are the same. And our choice for that something is second theta plus tan of theta. So what I mean by this is you can restate this integral as second theta times second theta plus tangent of theta over second theta plus tangent of theta. Theta. We don't need a brackets. All right, so we have this, and then we can multiply. So this is like second theta of 1. We're going to multiply these fractions together. So we have 1/2 times second squared theta plus second theta tangent of theta over second theta plus tangent of theta, theta. All right, so here, at this stage, you will have to suspect that there's something like we can do here, that is related to perhaps a substitution. So why don't we try to evaluate the derivative of secant of theta and tangent of theta? So let's recall again. So we have tangent of theta. If we is a tangent of theta can be restated as sine of theta over cosine of theta. If you differentiate this with respect to theta, so let's just assume it's a differentiated with respect to theta, you have, so this becomes what is it called? So you have derivative of sine of theta is cosine of theta, and then you multiply it by the denominator, and then minus sine of theta times the derivative of cosine of theta, which is minus sine of theta over cosine squared theta. So you have cosine squared theta plus sine squared theta over cosine squared theta. And the numerator here, according to our identity, is equal to 1. So that means this is 1 over cosine squared of theta. And don't forget that 1 over cosine of theta is the definition of secant of theta. So that means this is secant squared theta. All right. So that means we know that the derivative of tangent of theta is secant squared theta. What about the derivative of secant of theta? So let's refresh our mind here. So to differentiate this, we can restate secant of theta as 1 over cosine of theta. And then using the quotient rule, we get, so we have the derivative of 1 times cosine of theta. So this is just 0 minus 1 times the derivative of cosine of theta over cosine of theta squared. So this is 0. And then we have minus 1 times minus sine of theta over cosine squared of theta. So you have sine theta over cosine squared theta. Now notice that we can separate the two powers of cosine theta. So you have sine theta over cos theta times 1 over cosine of theta. So here, this is the tangent of theta, and here this is secant of theta. So what that means is the derivative of secant of theta is secant theta times tangent of theta, and the derivative of tangent of theta is secant squared of theta. Notice that the numerator has both the derivative of tangent and secant, which means we can do another substitution. So if we let t equal the secant of theta plus tangent of theta, so we have to let the whole denominator here. Oh, sorry, this is too tight. Secant of theta plus tangent of theta. So that means dt would be equal to, so derivative of secant of theta is secant theta times secant theta plus tangent times tangent of theta. So secant theta tangent theta plus the derivative of tangent of theta is secant squared theta. So it's all times d theta. So what that means is this integral is equivalent to 1/2 times, so this entire numerator becomes dt, and then the denominator is just t. All right, so there's a sine integral, which is 1/2 times natural logarithm of t. Okay, I know I used to write natural logarithms as log, but this is just reflex. So log is ln is also a natural logarithm, in case you usually use log without any basis. Okay. Or, okay, you know what? Just to be consistent with previous videos, let's go on to write as log t. So the result is the log of absolute value of t. Now, we have to work backwards and just substitute all of the we have to back substitute basically. So like we have to return all of this into the world into the variable of x. So we have 1/2 log of the absolute value of, so because t is equal to secant of theta plus tangent of theta, we can write it here. And then we have to denote what secant of theta and tangent of theta are in U. So remember that we assume U to be sine of theta. So because U is equal to sine of theta, that means we can draw some sort of an aiding triangle here. So if this is theta, that means U would be here, and then there is 1 here. Because so if we were to evaluate sine of theta, we would get the same result here. And then the remaining side here should be 1 minus U squared. So in this diagram, what is secant of theta? The secant of theta is 1 over cosine of theta. Or if you remember what a cosine is, that is the, so remember SOHCAHTOA, right? SOHCAH, that means adjacent over hypotenuse. But because we are evaluating secant, that means we have to flip it. So it is 1 over square root of 1 minus u squared. And then for tangent of theta, the tangent theta is u over 1 minus u squared. So we just put this into the result. So you get the log of 1 over square root of 1 minus u squared plus u over 1 minus u squared. And then remember that u is equal to x squared. So that's the final substitution that we'll have to make. So 1 over square root of 1 minus x to the power 4 plus x squared over square root of 1 minus x to the power 4. So from here, we have to simplify this form into 1 plus x squared over square root of 1 minus x to the power 4. Here we can factorize the denominator inside the square root. It's going to be square root of 1 plus x squared times 1 minus x squared. Right. Now, here, there's 1 plus x squared. There's another here. That means we can cancel out 1/2 of a power of 1 plus x squared. So what that means is we can cross out this, and then this numerator becomes 1 plus x squared to the power of 1/2, or square root of 1 plus x squared. So what that means here is you have 1/2 times log of the square root of 1 plus x squared over 1 minus x squared. Like this. And I don't think you can simplify this any further. So here's our final answer. Did you get it correctly? Let me know in the comment section below. So yeah, that's all that I have today. Hope you guys enjoy it. I'll see you in the next video. Bye.